Okay, so here's example 3, which is very similar to example 2. I have one equation that's in standard form and one equation that's in slope-intercept form. So I see here that y is equal to negative 2x minus 3. And over here, I see my y. So I'm going to take what's equal to y, negative 2x minus 3, and I'm going to substitute it into this equation where I see the y. Now, you have to be very careful when you're doing this step. Whatever you are substituting into the equation, you always want to wrap it in parentheses. So I have 3x plus 8y equals 2 as my original equation, but I am replacing this y with negative 2x minus 3, this whole thing. So now I have, instead of writing y, I'm going to write negative 2x minus 3. And then finish off the rest of my equation. Okay, now when it comes to solving this equation, there's quite a bit that I have to do. The first thing I have to do is apply the distributive property. So I'm going to do 8 times negative 2, which is negative 16x. I'm going to do 8 times negative 3, which is negative 24. And I'm going to bring down everything else that I haven't dealt with yet. Now I'm going to combine my like terms. So here are my like terms. I get negative 13x minus 24 equals 2. Now I'm going to add 24 on both sides. So I have negative 13x equals 26. And I'm going to divide both sides by negative 13. So I get x equals negative 2. So remembering that my final solution is going to be an ordered pair, I have found the x value to be negative 2. Now, I'm going to go back to one of my original equations, and now I'm going to solve for y. First thing I have to do is plug in negative 2 for x. So it doesn't matter which equation you use because you will end up getting the same answer. So I'm going to use this one because for me I find this one to be easier. So I write my original equation. And now where I see x, I'm going to replace it with negative 2. So negative 2 times negative 2 is 4, minus 3. So y equals 1. So my final solution is negative 2, 1.